So without using a calculator, we want to solve this cubic equation. So solving a cubic equation, we really will need to get one factor to start with, and we can use the factor theorem for that. So I'm going to say, well, f of c is 6c cubed minus 7c squared plus 1. And actually this one's really easy because f of 1 is going to be 6 take away 7 plus 1, which is 0, which tells me that c minus 1 is a factor. So then I've got c take away 1 and then a quadratic. So to get 6c cubed, I need 6c squared. To get the plus 1 on the end, I need a minus 1. I don't know what's going in the middle, so I'll call it just ac. And then we can do that by comparison. So we know, for example, that the coefficient of c is 0 in the original up here. So we can say 0 equals, what's going to give us a c from here? We'll get minus ac minus c. So that tells me that a is -1. So I've now got c minus 1, 6c squared, minus c minus 1. So let's think about that 6c squared minus c minus 1. I think we can factorize that. So if I do 3c and 2c, 1 and 1, make this one a minus and this one a plus, that does it. So c is -1/3, or c equals 1/2. And don't forget the c equals 1 that we found before. Don't need the or in there. So we're given that y is equal to tan x plus 6 sine x, and we want to find dy dx. So that's actually quite easy, provided you remember tan differentiates to sec squared, so it's just sec squared x plus 6 cos x, because sine differentiates to cos. Nice and easy. If dy dx is 7, show this. So what we've got is sec squared x plus 6 cos x is equal to 7. So remember, this one is 1 over cos squared x plus 6 cos x equals 7. Multiply through by cos squared x. So we get 1 plus 6 cos cubed x equals 7 cos squared x, which will give me 6 cos cubed x minus 7 cos squared x plus 1 is equal to 0, which is what we were trying to show. Hence, solve that equation, and we want it where x is between 0 and pi. Well, looking back up here, we've got 1, -1/3, or 1/2. So cos x is equal to 1, -1/3, or 1/2. Okay, so cos x equals 1 only when x is 0 in this range. 0, and then the next one is 2 pi and so on. So that's the only one that will come from there. So what about the half? So ASTC, inverse cosine of 1/2 is pi by 3. And the other one will be down there. So pi by 3 we can have a -1/3. There's likely to be one in here. So we need to be in radian mode. So we're going to do the inverse cosine of negative 1/3. And that's 1.91 radians.